So what is the impact of these marine outfalls? So at the moment, the sewage is going into the sea and it's screened through a 3 millimeter screen. That's all that happens. So it takes out gross objects. And there's plenty evidence that there is a problem, that the sewage is actually coming up to the surface of the water. I'll just skip through these slides, but that is sewage lying on top of the sea. Here you can see the sewage plume heading back towards Cape Town. That is the actual sewage distribution point in the ocean. So it looks white because of all the toilet paper. And there's the one in Hout Bay showing you the sewage. Now that sewage often hits the coastline. I've seen it frequently. And here was where the desalination plant was going to be, just about 200 meters down from where the marine outfall was going to be. So we put up quite a fuss about that, and then they moved the desalination plant from there into the harbor, which is 10 times more contaminated. Okay, so basically I showed you the pathways earlier of how these contaminants get into our water supplies, but basically there would have been another loop. And the trouble was that the desalination water was going to be pumped straight into the city's supply without any bulking and testing. They assumed that the reverse osmosis system was adequate for taking all the contaminants out. I suppose I should use a German term now, Schadenfreude, if you know what that is. They've had to close down the desalination plants. And one of the main reasons was because of all the sewage going into the ocean, we have had huge algal blooms, which can be seen on satellite photos. And those algal blooms have blocked the reverse osmosis systems, and the desalination plants have been down. So desalination is not the cure-all that it's punted to be. And then I just want to show you where those chemicals end up. So we went around the coastline and in the ocean, and we took samples of marine organisms and seawater, and we tested the marine organisms in the seawater and the beach sand for these compounds. Now there's the chemical carbon in all its glorious diversity. Do you see it? In all its wonderful non-obsolescence. So we went and we got limpets, mussels, sea urchins, starfish, and seaweed, and we went and investigated them for about 20 different compounds. So here is the Camps Bay water compared to the Greenpoint water, and you can see the green, sorry, these are organisms and water. Let me just see where's what. Oh no, this is no water, it's just the beach sand and the marine organisms. So please look at the scale bar down here. 800 nanograms per gram and 12 nanograms per gram. So that gives you an idea that the Greenpoint marine discharge is working a bit better because there's more movement of the ocean. Whereas in Camps Bay, the sewage is being discharged into a fairly closed bay, and the sewage is not being flushed out there. And it's accumulating in these in these marine organisms. Now what, please tell me, is a mussel doing full of caffeine? And what effect might that have on a mussel? And it wasn't the only compound that we found in that same mussel. We found a whole suite of perfluorinated compounds, the stuff that we're using for keeping pans non-stick, and for keeping carpets clean so that you don't, stains don't go in them. So it's made for stain resistance. Perfluorinated compounds, huge problem. There are big class suites, legal battles being fought in America at the moment about the perfluorinated compounds because they're hugely toxic, and our marine environment is completely contaminated. Then we went to Cork Bay Harbour and we went and bought some fish. And what did we find in the fish? There, for instance, we found the perfluorinated compounds and a whole host of other compounds, but we found nearly 2,000 nanograms per gram of diclofenac. in the snook. Diclofenac is a medicine that people take as an antispasmodic. So if your muscles are cramping, it ends up in the snook. And this shows you the problem of bioaccumulation in the environment of carbon-containing compounds. So if you thought metals were the only thing we should worry about, I hope I've given you something else to think about today. And I just want to say we're large mammals, but we need to realize that we're also probably somewhere on this extinction curve in one way or the other. Because this is what's happening to our species worldwide. I don't know if you noticed the other day there was a report that we're losing something like 2.5% of our insect diversity every year at the moment because of our overuse of pesticides. Oh, I forgot to mention, we found a whole host of pesticides and herbicides in the fish as well. And some of those pesticides and herbicides are banned in EU and other countries. We're still using them here. So we're spelling the end of the road to many creatures. And you can see how the species are busy dying out. And we must not think that we're exempt. So to close off, you need to remember that pharmaceuticals are fashioned to respond at low physiological doses. They perform best at nanogram per kilogram concentrations. They interact even at low dose with multiple non-therapeutic receptors. We're talking about multiple mixtures of pharmaceutically active substances, and that there might be synergistic effects between those compounds. It's difficult to know what the exposure rate versus the actual dose is, but as a fish or a mussel has no option. He is in that water 24 hours each day, and that sewage is being pumped out in megaliters each day. So there's no opportunity for that sewage to disperse. And if this is happening with the fish in the sea, it's happening in our rivers all over our country. And remember, cattle don't drink out of taps. Cattle go to rivers and drink out of rivers. So if the river is contaminated, your cow is being contaminated, and your milk, the milk in the cow will be contaminated because these compounds are lipophilic. They like fat, and they go to the milk. And we've shown that there's a very high bioaccumulation potential. So the issues that we need to consider, and I think the Department of Environmental Affairs and the Department of Fisheries all should be taking note of this. Which compounds should be monitoring? We can't monitor for all of them, so we need to find some indicator compounds to monitor for. And we need to consider what levels of these compounds are deemed safe for drinking water, and how do we determine that safety? There are international recommendations that we can follow. We also need to pay attention to the fact that they're very resistant to wastewater treatment, and we have to take note of their persistence. We also have a very big problem in detecting them, and our removal capabilities at our water treatment plants is simply not adequate, and it depends on the plant's characteristics. And we can't just consider the daily intake for humans because we're reliant on the food in our environment. And remember, if you're irrigating water, your agricultural land with reclaimed water, you are spraying this stuff all over your crops. If you're putting the sludges on the ground to enrich the carbon, you are incorporating these compounds into the ground. So my recommendation is that we need great caution with unconventional water sources. We really need to include tertiary processes after the primary and secondary treatment step, and we need to use combined advanced oxidation if we're going to use it. And we have to treat those sludges as very hazardous, and we really need to implement more barriers than we are implementing. And we need to test drinking water for toxicity. Now I've left this last point for last because it is something to consider. You don't need to test for every compound. You can get yourself a toxicity lab and test for when small organisms die. I don't know if you know how toxicity is usually done. You take Daphnia or little frogs or little fish and you dose them with the water in question. And you see how much of that water you can give to those little creatures before 50% of them die. That's called the lethal dose 50. And that usually tells you how toxic that water is. Just for the reference, that water that we got from wastewater treatment plant A at Beaufort West didn't pass the Daphnia toxicity test at all. Okay, so fluit my story is uit.
Fantastic, thank you so much.